So to understand the concept of angle bisectors, first let us understand about the four quadrants that two lines divide the plane into. So if you take any two lines a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. These two lines divide the plane into four parts. So let us say the first part, second part, third part and fourth part. So similar to xy axis dividing the xy plane into four quadrants, any two lines for that matter divide the plane into four parts. Now, as we have already seen, so if you take the line a1x plus b1y plus c1 is equal to 0. So all the points on this line satisfy the equality equal to 0. All the points on one side of the line satisfy one of the inequality, for suppose greater than 0. All the points on the other side satisfy the other inequality less than 0. So let us say that this is the side which satisfies this expression is greater than 0. That means if you take any point in this region, in the first and second regions, and substitute the point on the first line, so you get a number which is positive. So the first and second regions are positive regions with respect to the first line. So if these two are positive regions, obviously these two have to be negative regions with respect to line 1. Now let us go for line 2. Again, all the points on this line satisfy the equality equal to 0. Now, all the points on one side of the line satisfy the inequality greater than 0. All the points on the other side of the line satisfy the inequality less than 0. So let us say that with respect to line 2, this is the positive region, this is the negative region. That means all the points on this side will make the second line expression as positive. All the points on this side of the region make the second line negative. That means if you take the four regions, in one region, both, if you take the points in this region and substitute in the first line, you get a positive number. In the second line also you get the positive number. In the second region, you get the first line as positive, the second line number as negative. Minus minus, both negative. First negative, the second positive. Or you can see that in these two regions, both the points give the same sign when substituted in both the lines. So if you take a point here, if you substitute this point in this expression or in this expression, both will turn out to be positive numbers. And if you take a point in this region, if you substitute here and in this line, both will turn out to be negative numbers. That means in these two regions, both the numbers will be of the same sign. In these two regions, both these numbers are of the opposite sign. So I hope you understood this concept very well. Now let us go forward. Now, what is an angle bisector? So if you have two lines, L1 is equal to 0 and L2 is equal to 0, what is the meaning of angle bisector? The angle bisector is the locus of points equidistant from the two lines. That means if a point has to lie on the angle bisector, but suppose this is a point, if this point is equidistant, that is the perpendicular distances are equal from both these lines, then this point will lie on the angle bisector. So if you draw the angle bisector, so angle bisector will be the locus of points equidistant from these two lines. So how do we find the locus? So let px comma y be a point on the angle bisector. Now what should be the condition that this x comma y has to satisfy? This perpendicular distance has to be equal to the perpendicular distance. And what is the formula for perpendicular distance? Modulus of, just need to substitute this point on this line. a1x plus b1y plus c1 by root of a1 square plus b1 square is equal to, what is the perpendicular distance of this point xy from the second line? Mod of a2x plus b2y plus c2 by root of a2 square plus b2 square. So this implies if mod of this is equal to mod of this. So if you remove the mod, so you get mod of the first expression is equal to mod of the second expression. That means first expression, whatever is this expression, is equal to plus or minus of the second expression, right? So if mod of two expressions are same, then the expression inside the mod is equal to plus or minus of the second expression. So a1x plus b1y plus c1 by root of a1 square plus b1 square is equal to plus or minus of a2x plus b2y plus c2 by root of a2 square plus b2 square. So this will give you the two angle bisectors. So plus is equal to plus gives you one angle bisector. Minus is equal to minus is also the same angle bisector. So if you take both with same signs, you get one angle bisector. If you take both of them with opposite sign, you get the other angle bisector. So that's why we don't take plus and minus here. We just take plus here. So plus is equal to plus gives you one angle bisector. Plus is equal to minus gives you the other angle bisector. So which angle bisector is which? So what is the angle bisector of the angle containing the origin and not containing the origin? So let us look into that. Now let us try to look at the angle bisector of the angle containing the origin. So to find this, what are we doing? So as we have seen in the first step, we are making both C1, C2 as positive. We are making both C1, C2 as positive. So what are we effectively doing by doing this? So now once we make C1, C2 positive, let us assume that C1, C2 are positive. So both these lines have positive constants. The meaning of that is nothing but when you substitute origin in the first line, when you substitute origin, that is 0, 0 in the first line, you're getting C1. When you substitute 0, 0 in the second line, you're getting C2. Effectively, we have made both these numbers as positive. That means effectively we have sent the origin into this plus plus region. We have sent origin into this plus plus region. So every point in this region will have both signs as positive. So if you take a point on this region, a1x plus b1y plus c1 will be positive and a2x plus b2y plus c2 will also be positive. So we just need to equate plus of this is equal to plus of this to get the angle bisector of the angle containing the origin. So if we equate plus is equal to plus, effectively we are saying that both these numbers are positive or both these numbers are negative. Effectively plus is equal to plus is same as minus is equal to minus. So these two signs will get cancelled out. So effectively by making C1, C2 as positive, we are sending origin into the plus plus region. And once we have sent origin into the plus plus region, all the points in the angle bisector containing the origin also gives you plus plus signs or minus minus signs. So we equate the expressions having the same signs to get the angle bisector of the angle containing the origin. So if you equate plus is equal to minus, you get the angle bisector not containing the origin. So once you see this, you can also think of how to find the angle bisector of angle containing any point other than origin. So if you want the angle bisector containing the point 1, 3, so we just need to put this point 1, 3 in these lines. If both of them gives you the same sign, then plus is equal to plus gives you the angle bisector containing this point. If both the lines gives you opposite signs when you substitute 1 is equal 1, 3, that means plus is equal to minus gives you the angle bisector of angle containing this point. So I hope you are understanding what is going on. Now let us look at how to find acute angle bisector and obtuse angle bisector. Next, if you want the angle bisector of acute angle or obtuse angle bisector of acute angle, angle bisector of obtuse angle. So what I try to do is, I try to find out whether my origin is in the acute angle or obtuse angle, because I already know how to find the angle bisector of the angle containing the origin. So to find acute and obtuse angle bisector, I just try to find in which angle is my origin lying. Is my origin lying in acute angle or obtuse angle? If my origin lies in acute angle, then the angle bisector containing the origin will be the acute angle bisector. If origin lies in the obtuse angle, then the angle bisector of the angle containing the origin will be the obtuse angle bisector. So what I am trying to do is to see whether origin lies in acute angle or obtuse angle. So to do that, let us make use of the normal form of straight line. Normal form of straight line. So first you have lines a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0. We have already seen how to convert this into normal form. So a1x plus b1y is equal to minus c1. So we have already done c1, c2 as positive. As we have seen in the algorithm, c1, c2 is initially made positive. So obviously minus c1 is a negative number. So this minus has to be sent on this side. And you need to divide by root of a1 square plus b1 square to convert this into normal form. So the normal form is nothing but minus a1 by root of a1 square plus b1 square times x plus minus b1 by root of a1 square plus b1 square times 1 is equal to c1 by root of a1 square plus b1 square. So this is the equation of line in normal form. So this term, whatever is this is nothing but cos theta 1. This is nothing but sin theta 1. Because the normal form is x cos theta plus y sin theta is equal to perpendicular distance. Theta is the angle made by the normal with x-axis. So what is the normal form of this line? Minus a2x plus minus b2y is equal to c2 by root of a2 square plus b2 square by root of a2 square plus b2 square by root of a2 square plus b2 square. So on comparison, this will be my cos theta 1, this will be my cos theta 2, sin theta 1. Because we have supposed that the normal from origin makes angle theta 1 with x-axis. So the equation should look like x cos theta 1 plus y sin theta 1 is equal to the perpendicular distance 1. So x coefficient is nothing but cos theta 1, y coefficient is nothing but sin theta 1. So here x coefficient is nothing but cos theta 2, y coefficient is nothing but sin theta 2. Now as you can see from this diagram, what is this angle? This angle made between the normals at origin is nothing but theta 2 minus theta 1. So let me see whether this angle is acute or obtuse. To find whether this angle is acute or obtuse, let me find cos of theta 2 minus theta 1. So what is cos of theta 2 minus theta 1? It's nothing but cos theta 1 cos theta 2, that is multiply these two, minus into minus gets cancelled. So a1 a2 plus sin theta 1 sin theta 2, that is you multiply these two, b1 b2 by root of something into root of something. Now as we know, if cos of theta 2 minus theta 1 is positive, then this angle is acute. If this is negative, then this angle is obtuse. The denominator is always positive because the root of this and root of this are positive. So the sign of this depends only on this. The sign of this depends only on a1, a2 plus b1, b2. Now, cos of theta 2 minus theta 1 is nothing but, if you see this quadrilateral, this angle is 90, this angle is 90. So the sum of these two angles, alpha plus theta 2 minus theta 1, has to be equal to 180 degrees. The sum of these two angles is 180. So the sum of these two angles should also be equal to 180. So this implies theta 2 minus theta 1 is equal to 180 minus alpha. So let me substitute this here. So cos 180 minus alpha is minus cos alpha is equal to a1 a2 plus b1 b2. This implies cos alpha is equal to minus of a1 a2 plus b1 b2. So if alpha is acute, then this has to be positive. Then a1 a2 plus b1 b2 is negative. So if a1 a2 plus b1 b2 is less than 0, this implies alpha is acute, right? a1 a2 plus b1 b2 is negative. So minus of minus will be positive. So cos alpha is positive. So alpha is acute. That means origin lies in acute angle. Origin lies in acute angle. So if a1 a2 plus b1 b2 is negative, then origin lies in acute angle. Similarly, a1 a2 plus b1 b2 is positive, implies cos alpha is negative, so alpha is obtuse. So as simple as this. So if a1 a2 plus b1 b2 is negative, origin is in acute angle. If a1 a2 plus b1 b2 is positive, origin lies in obtuse angle. So once you know where the origin lies, you know how to find the equation of the angle bisector containing origin. So if a1 a2 plus b1 b2 is positive, then as we have seen, origin lies in obtuse angle. So plus is equal to plus gives you obtuse, and plus is equal to minus gives you acute angle bisector. And if a1 a2 plus b1 b2 is negative, we get the opposite. So before going forward, let me summarize whatever we have derived once again.